So information security is about balancing two extremes. So at one extreme, we could have absolute security, absolute protection, theoretically, just philosophically. Let's kind of play this out to its ridiculous conclusion. I could have perfect security by unplugging my firewall, so no connection to the outside world, and replacing all of my employees with robots. I would have near perfect security. However, I would have no access because I've unplugged my firewall. I wouldn't be able to do the job. I wouldn't be able to achieve the objectives and goals of the organization. So, and at the other end, I want everybody to be able to do their job. I could just wide open. Anybody can install any software. They've got full administrative access to their PCs and the servers and the routers and switches and firewalls and access points. Give them full access to everything. They have everything they need to do their job. That's a terrible security plan. So somewhere between those two extremes is the sweet spot. And that sweet spot is different for every organization. For some organizations, military organizations, government organizations, they may lean more towards the security side of things. And other organizations, maybe a nonprofit that doesn't have a lot of sensitive information, might lean more towards the access side of things. But it's always going to be a sweet spot between these two. So that's why we talk about a reasonable balance, to balance security with a reasonable amount of access, while at the same time protecting against threats. And most information security classes use some kind of graphic like this to graphically illustrate the point. But of course, the million-dollar question is, who decides? Who decides what that sweet spot is? Is it IT? If that's your answer, you are barking up the wrong forest. IT does not get to decide what the security requirements are for their organization. They might implement them, the majority of them. They might enforce some of them, not all of them, because really it's the job of managers to enforce policy and procedure. So upper level management, the executives, have to be the ones who decide that A, the business needs of their organization, and then A, the business needs, and B, the security requirements, at least at a high level, to give guidance to the middle managers who are going to be implementing it. So this graphic from the book, this is from the book. Notice the top-down approach. The CEO, everything flows down to first level IT support. Whereas some organizations that kind of rely on the network administrators to be responsible for all the security and take care of it, where the CEO says, oh, security, that's IT's job, and delegates it all the way down, that's a terrible plan. It's not a plan at all. It's a recipe for disaster. So if we're talking about business requirements, you're ready to talk about stuff that really you've already talked about in system design analysis class, which is the SDLC and this waterfall methodology. I realize some of you are going to be more comfortable with an agile or Scrum, more of a flexible way of doing project management, but let's just stick with the traditional format first. If you're already comfortable with this, you should be comfortable with the idea that in every single phase of this, there's a piece of security. There's some steps around information security to protect our information assets that needs to happen every step of the way. Same phases, so nothing new to memorize, just some additional stuff. That additional stuff in the book. It's way too small for me to read this off to you. Find this table in the book, circle it, star it, photocopy it, scan it, take a picture of it with your phone. Do something, but this is the stuff. This is the stuff you need to know. This is the stuff you need to know. It's that important. It's all on that table. Maintenance and change, the last phase in SDLC. This is, I'm biased because all of my IT management background has been more or less on the operational side of things. So maintenance, change, day-to-day operations, support of infrastructure, IT hardware and system software. from my perspective, this is the most important. Now, if you're a project manager, probably the first phase is the most important. But if you're an operational person, this last stage is the most important because it's the ongoing effort. So a project is going to end at some point and turn over to a service that your operational personnel have to support until the end of time, until something new comes out. And in our environment where there are new threats every single day to deal with, this is the exciting area. It's typically in project management, maintenance and change is not glamorous, but for security, that's what makes security different. This is the important stage, much more so than the initial stages as we teach in project management. So information security kind of flips things on its head in terms of emphasis. So in order to keep up with the changes that we're talking about, the latest threats from week to week, we need to figure out how we're going to do that. Are you going to do that by taking a class in college? No. At best, we can just take a cross-section, a time slice of what's going on right now in the world, but you need to continually update your knowledge. So most security professionals have a list of sites that they use to keep up with. What I want you to do is when you're suggesting your websites at the beginning of class, ones that you found have good info, we're just going to make a list, and we're going to build this list throughout the semester so that by the end of the semester, you'll have your starting list of what to keep up with. Should work out well. The idea of software assurance has become very trendy. But again, I'm a hardware person. I'm not a programmer. If you are a programmer in application development, you really want to bone up on the aspects of software assurance. I can't even say it. So the idea is to build security into the software that you're creating. And there's a big book of knowledge that describes all this. There's a nice summary in the book in terms of the principles of software assurance, building security into your software that you're writing. This is all programming stuff. This is not my thing, and this is not a class in programming, but just something to be aware of. The more interesting notion is this one, though, this question. What regulatory body enforces the proper use of those software assurance controls? What organization? There is none. Nobody. There's nobody to enforce it. It's purely voluntary. Scared yet? Just wait. In addition to the SEC-SDLC framework, which is very straightforward, there's another framework that has gained a lot of traction, especially in the U.S., and that's NIST. Whether you say NIST or just NIST, it's the same thing. It's a National Institute of Standards and Technology came up with a framework a while back that talks about all the key security activities in a sequence of phases that more or less line up with SEC-SDLC, but in a lot more detail. And let me just show you very quickly where you can find these. If you go to NIST.gov and click the link for the National Cybersecurity Center of Excellence, you'll get to this page, which has a very large and impressive library of information. If you talk to most security professionals these days, they're very familiar with NIST and use their documents, their framework, for a lot of their internal policies and procedures. We'll get into in a future chapter how to incorporate a lot of these standards into your policies and procedures, but I want you to see that this information is freely available. So the first phase of NIST, the initiation phase, similar to the initiation phase in project management, outlining the business requirements in terms of CIA, confidentiality, integrity, availability, just figuring out what the business requirements are and then what the privacy and security requirements are for your project. The development and acquisition phase, the key security activities, doing your risk assessment. We'll talk about how you do a risk assessment later on, and analyzing the specific security requirements and getting a little more into technology at this point. In the first level, first phase, you're looking at a very high abstract level about what the requirements are for security, and in this next phase you're digging in a little deeper. In the implementation phase, implementation assessment, so you're doing it and then you're measuring your success. part of your success is testing out the new security controls. So basically, everything you're going to roll out in an organization, be it a new piece of hardware, a new piece of software, a new service, there's going to be some information system supporting that business process, which means there need to be some kind of security controls built into that new process. Some of the security controls might be policy and procedure, some might be technical, some might be people and training. But these need to be tested in the implementation phase. Notice that NIST has an operations and maintenance phase, just like SDLC, and where they emphasize continuous monitoring. And so, of course, most security professionals are doing nothing but monitoring the environment for irregularities, for breaches, for disruptions, and performing reauthorization is required. So the idea is that you should have some kind of internal certification process where you don't just set it and forget it and you assume everything's okay. That, for example, every year you go back and review your security policies and update them every year, or more frequently, maybe less frequently, depends on the business requirements. You go back and look at if the hardware is appropriate, if the software is appropriate, if the controls are in place that meet the needs of the business. But then NIST goes a step further. It doesn't end with maintenance and operation. They actually include a disposal phase. And this is especially important for security, so getting rid of information, archiving it securely, or deleting it securely. Just throwing something in the trash can or recycle bin on your desktop, that doesn't really delete it. Doesn't delete it at all. So sanitization of media could be as simple as taking a hammer to an old hard drive to make sure nobody can access the data on it. Maybe it means using a piece of software to write a sequence of ones and zeros over the media so nobody can recover any of the data on that media. There are a variety of ways to sanitize media, but you can never just throw a hard drive in the trash can. Somebody's going to go dumpster diving and find it and get sensitive information off of it. As we take this journey together, you're going to find there are a lot of frameworks. In this course, I'm going to emphasize SecSDLC and NIST heavily. The book is in love with NIST. There are others. There's ISO, there's ITIL, there's COBIT. There are a lot of different security frameworks out there. Microsoft has their own version of a security framework in 16 phases. Oh my God, to know me is to know that I really despise Microsoft. There's a long history there, and don't hold it against me, but I just laugh at Microsoft's version. There you have it. So to recap what we've talked about so far, you can either be old-fashioned and think in terms of a dedicated security project and use SecSDLC. That's a fine framework. But I think if you think in terms of individual IT security projects, you're thinking the wrong way. You should think in terms of all projects. Every single project should use SecSDLC, because every single project, it's hard to think of a project that does not have a security element that needs to be addressed. Some more so than others, but it needs to be addressed during every single project. And I don't care what kind of framework you use at work, as long as you're using some kind of framework, which begs the question, if you're working currently, and I know most of you are someplace, it would behoove you to find out, what framework does your organization use? Do they use NIST? Do they use SecSDLC? Do they use ISO, ITIL, something else? Find out. It'd be good to know. And I just want to circle back to the first point that we started off the chapter with, that IT is a management problem, not a technology problem. But why does everybody think this? Why do we think that security is just IT's job to figure out? I think historically the reason for this is because security is typically a department that falls under IT. I'm a big advocate of the security problem should not be the security department should not be under your IT or IS organization. It should probably be under HR with your legal folks. Some people even have this under accounting, but the majority of organizations today have it under IT, which I think gives a false conception, and this leads to siloed thinking. Everybody just thinks it's IT's problem, not their problem. It's bad. And the last section in the book gets into the actual field of working in security, and we'll talk about some different roles and responsibilities in the final video for Chapter 1.